Okay, so here we'll work through the first 5 questions of the second practice paper, which is the calculator aloud paper. So question 1. A number is decreased by 12% of its value. This is done 3 times, each time decreasing the previous value by 12%. Circle the multiplier that you would use to find the value of the 3 after the 3 decreases. So this is a compound percentage question, which we practiced when we were getting ready for the numeracy paper. Your original amount is 100%, so you start with your 100%, and because it's being decreased, then you're going to take off the 12%. So you're going to end up with 88% of your original amount. So when we were practicing this for numeracy, I was telling you that you'd be, whatever the value was, you'd be multiplying by 88% to the power of however many reductions there were. So in this case, that would be 88% to the power of 3. But you can see here that they're not using the percent button, they're turning the 88% into a percentage, into a decimal value. So the 88% as a decimal would be the same as writing 88 pence written in pounds, which would be 0.88. So multiplied by 0.88 to the power of 3. If it had been an increase of 12%, then you'd been doing 100% plus 12, so you'd have 112%, and that then as a decimal would be 1.12. Calculate the percentage change when 42.5 is increased to 45.9. So to work out a percentage change, again we practice this for the numeracy paper. It's the amount of the change divided by the original multiplied by 100. So the amount of the change is going to be 45.9 less 42.5 divided by the original, which is the 42.5, multiplied by 100. And you can put that onto your calculator exactly as I've written it there. Let's just get that glare off. So fraction button, 3.4 on top, 42.5 underneath, times 100. So that's an 8% increase. So whether it's an increase or a decrease, it's always the same. It's how much the change is divided by what the original amount was that it was increased from or decreased from, and then multiplied by 100. Question 2. Display the following information in a Venn diagram. So the universal set is all the integers between 74 and 80 inclusive. So let's just write those. Integers are whole numbers. Inclusive means it includes 74, 75, 76, 77, 78, 79 and 80. So that's all our numbers that are in the set. The even numbers, so A will be 74, 76, 78 and 80, and the multiples of 3, well, we can check those just by dividing each of those by 3. So 74 divided by 3 isn't a multiple. 75 divided by 3 is. 76 divided by 3 isn't. 77 divided by 3 isn't. 78 divided by 3 is. 79 isn't, and 80 isn't. So those are, so A are the even numbers, B are the multiples of 3. When you draw a Venn diagram, it has to be in a box, and the box will contain all of those numbers between 74 and 80. We then overlap our two subsets, set A and set B, and starting in the middle, what is in A and B, which is 78. So 78 is in that intersection because it's part of that and it's part of that. Set B, so we knock 78 out of that one as well. Set B will then have 75 in it. Set A will have 74, 76 and 80. 74, 76 and 80. 74, 76 and 80. And then in the box outside the two circles will be the numbers that didn't fall into set A or set B. So 77 and 79 will be in that outside box. So that's how you produce the Venn diagram for that information. So that's testing your knowledge of properties of number. You need to know what integers are, you need to know what even numbers are, and you need to know multiples of 3. Question 3. Indices. Simplify each of the following and circle the correct answer in each of these. So we got 6p to the power of 6 multiplied by 3p to the power of 3. So we just multiply the numbers together, so 6 times 3 is 18. So it could be that one, it could be that one, it could be that one. It's definitely not those two. Then when we multiply, so this is your learning from your properties of indices, when you multiply numbers or letters where the bases are the same, so they're both p, you can add their powers. So it's going to be 6 times 3 is 18, p to the power of 6 add 3, which is 9. So that's going to be 18p to the power of 9. So you've got your 6 times 3 times p to the 6 plus 3. 6 times 3 is 18. So there you go. This one, 3.4g to the power of 8 divided by 13.6 g to the 2. I'm dividing, so I subtract those. So I'm looking for one with g to the 6. So that's a g to the 6, that's a g to the 6, that's a g to the 6. It's going to be one of those. Now I'm going to do 3.4. Remember, you're allowed to use your calculator for any questions on this paper. So if I do 3.4 divided by 13.6, I can see I get 0.25. Now 0.25 isn't appearing on any one of those. However, I do know that 0.25 is the same as a quarter. Remember that SD button there will convert decimals to fractions or fractions to decimals. So I'm looking for the one that has a quarter, which is over 4. So that's that one. And then for this, they're all to the power base m. So I'm going to add 3 plus 6, and I've got to subtract 9 because I'm dividing. So 3 plus 6 because that's multiplied, take away 9 because that's divide. That means I get m to the power of 0. Now one of the standard results with indices that they test you on is that anything to the power of 0 is 1. So that one is 1. Question 4. A solution of the equation x cubed plus 2x equals 91 lies between 4 and 5. Use the method of trial and improvement to find the solution correct to 1 decimal place. You must show all your working. So this is again something that you practiced when I was off a couple of weeks ago. So first of all, let's list all our possible solutions. I'm looking for 1 decimal place. So between 4 and 5, that means it could be 4.0, 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, or 5.0. Any one of those is going to be my answer, correct to 1 decimal place. Now, in order to decide which, I need to search through these numbers and eliminate as many as I can. So we first of all start in the middle, because if that works out to be too big, there's no point trying anything smaller. If that works out to be too large, there's no point trying anything larger. So we say try x equals 4.5, and then we write that into our formula. Wherever we replace the letter, we break up as a bracket pair, and it's important that you write that bit down. This is your method. You must show all your working. Okay, we can use our calculator to do all the hard work for us now. So open bracket, 4.5, close bracket. Cubed is the shift x squared, plus 2, open bracket, 4.5. Press equals 100.125. We're looking for a value of 91. That's too large. So because that's too big, there's no point us trying any value bigger than 4.5. So now you're going to take a pick between 4.2 or 4.3. I'll try x equals 4.2. So 4.2 cubed plus 2 bracket 4.2. On the calculator, you don't have to type it back in. Just move up there. That becomes a 4.2. And that becomes a 4.2 equals 82.488. I'm looking for 91. That's too small. So there's no point me trying any value smaller than 4.2. So I know my solution is now either going to be 4.2, 4.3, 4.4 or 4.5. I'm going to try 4.4 next, say. So I write that down, go to my calculator, back up using the cursor, delete that, change it to 4.4. And 4.4, 93.984. I want 91, that's too big. So 4.4, I can now cross that out. So now my answer is either going to be 4.2, 4.3 or 4.4. And I have to keep searching until I've just got one of these boxes clear. So I've got to try x equals 4.3. Okay, so delete 4.3, too far, delete 4.3. That's equal to 88.107. Comparing to 91 is too small. So anything smaller than 4.3 is not worth trying. So now that's telling me that the value of x is going to be something between 4.3 and 4.4. Now I've just got to decide whether the value is going to round down to 4.3 or up to 4.4. One of these is going to be my final answer. What I've just done there is worth 2 out of the 4 marks. Okay, so there's 2 marks out of the 4 will be for getting it down to those 2 consecutive numbers. And then what you have to do, so that's 4.3, that's 4.4, we go halfway. So halfway between 4.3 and 4.4 is 4.35. So we test x equals 4.35. So 4.35 cubed plus 2 bracket 4.35. Back onto our calculator and just add a little 5 in there, add a little 5 there, 91.01, etc, 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 which is too big because I was looking for 91. So that's too big. So if that's too big, everything between 4.35 and 4.4 is too big. So my answer is going to lie between 4.3 and 4.35, and everything between 4.3 and 4.35 to 1 decimal place is 4.3. So that's too big. So x equals 4.3 to 1 decimal place. So 2 marks for getting it between there and there, 1 mark for the test, going halfway, one for one only time, and then the final mark is for correctly saying, well, if 4.35 is too big, everything above it is too big, so it must be 4.3 to 1 decimal place. Question 5. A solid object is made by drilling a cylindrical hole of radius 4 centimeters through a cuboid measuring 20 centimeters by 15 centimeters by 10 centimeters as shown below. Calculate the volume of the object. Give your answer in centimeters cubed. So the volume of the object is going to be the volume of that cuboid minus the volume of the cylinder which is going to be drilled out of it. The volume of a cuboid, you should know from Key Stage 3, is length times width times height. So let's do that first of all. So that will be 20 times 15 times 10. 20 times 15 times 10 is 3,000 cubic centimeters. So then we've got to work out the volume of the cylinder. And if you can't remember the formula for the volume of the cylinder, if you remember when we were looking at the quadratic formula last week, I showed you what's on the list of formulae that you're given on the GCSE paper. And this one, volume of a prism, is the area of the cross section times the length. Now a prism is basically a three-dimensional shape that if you cut it, it doesn't matter where you cut it, the surface area that you're cutting would be exactly the same. And a cylinder is just like that. These aren't prisms, because if I slice that, as I slice through the sphere, the cutting area is going to get bigger and bigger until I get past the middle, where it gets smaller and smaller. So a cylinder is a prism. The area of the cross section is the area of a circle, which is pi times the radius squared. You're not given that formula, you should know the area of a circle is pi r squared. and then that's going to be multiplied by the height of the cylinder, which is the same as the height of the cuboid, which is 10. So we are going to do pi, which on your calculator is above the times 10 to the power x. It will tell you on the front of the sheet to take pi as 3.14 or use the pi button on your calculator. It's up to you. If you use 3.14, then it'll round more quickly. I'll show you now. So if I use pi times 4 squared times 10, I get that. If I used 3.14 times 4 squared times 10, you don't get such a big string. That's the only difference. So if we go with that 502.4 centimeters squared, then the volume of the object will be the volume of the cuboid less the cylinder which has been drilled out to make a hole. So I'm going to do 3000 less 502.4, which is 2497.6 centimeters cubed. Now that question quite often would be a rounding question where they'd say give your answer to one significant figure or two significant figures. If it was two significant figures, it would be those two, but you look at the next one, it would round up, so it would be 2500. It's not asking us to round it there, so we leave it like that. The object is made from a material which has a density of 2.4 grams per centimeter cubed. Calculate the mass of the object. In science, when you meet density, you are given or asked to remember that triangle. DMV, density is mass over volume. If you can't remember it, the clue, they always give you the units for density in the question. Grams is mass, per is divide or over, centimeters cubed is volume. So density, D, equals grams mass over volume, which is the same as that. So if you can't remember it, you can deduce it from the units. Okay, so we want to work out the mass of our object. We know what the volume is, and they're telling us what the density is. Mass is density times volume. Cover up the mass, D and V are on the same level. So mass equals density times volume. Density is 2.4 grams multiplied by 2497.6. So I'm going to multiply that by 2.4 equals 5994.24 grams. To turn grams into kilograms, I divide by 1000 and I get 5.99 kilograms. Correct to the nearest kilogram is going to be 6 kilograms. So that's the first 5.